So in this video we'll see how to make one version of an embedded answer question. In general, you can do a lot of things with these kinds of questions, but we have an example here where it's we want students to input numbers, and we can input some numbers, and I'm just gonna input 3 random, not random numbers. And we're getting told that we've correctly selected 1, and we get some kind of hint of what to do. What you can see here is when I scroll over here or mouse over here, you can see that this one was correct, and these ones were not. So I know that when I try again, these are the ones I have to worry about. So luckily I know what the answers are, so I'm going to check it. And we get the information that it's correct. So how do we make these kinds of questions? Well, I'm going to go to a course that I have access to. I'm gonna, as an administrator or as a teacher, and I'm going to turn editing on. I'm going to either make a quiz or go to a quiz that I want to, in which I want to include my question. I'm going to press edit quiz and add question, add new question, and we have this here, add. So we're going to call it neutron distribution temperature. I'm going to write the question text here, and as you can see, you can use LaTeX code, but you just have to, instead of the usual way, you're going to use brackets and in the backslash like this. So I'm going to use a picture, and I'm going to find it on my own computer. It's called pic, and then test graph. And it doesn't need to be that big, maybe it's 800, and then also size it down, maybe even 600. Okay, and we're just going to say that is called a graph. Oh, there you go, a graph, save image. Okay, so now we're here, and I'm going to go a little bit further, there you go, and put in some more question text. So what we want the students to find out is the temperature corresponding to these 3 graphs, given the distribution up here. And the way we do that is we use the numerical functionality. And basically, this is this from the curly bracket here to the curly bracket here. This is what Moodle will judge the answers on. And what you see here is that the correct answer here is 100. That's and if you write numerical and then the colon and then 100, so the equal sign and then the 100, then it will register this as the correct answer. Now, if you have the hash tag here, or what do you call it, and then you can write some feedback. Here we just wrote yes. You could also write this is correct, or you could explain a little bit more about why it's correct. And then you have some numbers here that will allow you to respond to answers which are wrong. And you could maybe give more feedback than we have given here, and so on. So we're just going to put in 2 other, because we have 3 curves. So these are the possibilities. Now, these embedded answers, they have a lot of other possibilities that you can use. You can even put in an interval here, so that if you can say that it's 100 plus minus 10%, or 200 plus minus 10%, and so on. You can also make intervals and then say that are very large, and then so that you catch a lot of wrong answers and then just give them a general message that it's wrong. This is all possible. All you need to do is to search for or actually go up here, click the question, and then you can click more help. And you can see everything there is to know about these answers. After you have put in your text, and remember that your questions and the way the Moodle is supposed to respond to the questions and the student input is also in the question type here, in the question text. Now we're going to give some hints. And as always, we're going to set a penalty of 0, and we're going to make 4 hints in this. And the first hint is supposed to get students to begin with answering the question. So the shape of the curve is determined by the temperature T. Try to find a point on each curve that could yield information about that temperature. So we're hoping that that would get students started. Now, remember that it cleared my incorrect responses and it showed the number of correct responses. You can click that on and off here. And this is basically something about how helpful you want to be. Another hint we found useful is that you can normalize the flux without losing information about the shape of the curve. So the reason we include this is because students in our classes have had trouble with that. Now we're going to add another hint. And scroll down. Oops. And then if you find the maximum of the intensity, then you can compare it with the maximum of each curve and you should be able to isolate the temperature. But we can provide another hint, and that's the final hint we have for this exercise. So here we actually just tell them to differentiate the intensity. So once we're done, save the changes. If you had made mistakes, coding mistakes that Moodle did not understand, then it would have told you and you would not have been allowed out here again. But we didn't do that here, so we made no mistakes, and at least not the Moodle code, and here's how the question looks in the preview. Thank you for listening, and see you later.